Hey there, I got your question regarding the even root and why the domain on this is going from 0 to infinity and why on this one is going from negative infinity to a value. The reason is that negative right there that's attached to the x. So I'm not sure if you remember when you are working with inequalities, if you multiply or divide both sides of the inequality by a negative number, which is what I did right there, essentially you're going to see that when there's a negative coefficient on the x term. That flips the direction of the inequality. So if I have, negative 4x greater than or equal to negative 9, as I did, once I divided that negative 4 on both sides, that's going to reverse the inequality every time, and that's how that got to be a less than. In terms of, and so that goes for solving any inequality equation. In terms of the graph, we can look at it, and so I pulled it up in Desmos here. Square root x makes sense. X is 0, y is 0, x is 1, y is 1. We put in a positive 4 in there, we get out a 2. It doesn't make sense to put square root of negative 4 because there are no two numbers that multiply to be a negative. But watch what happens if I throw a negative on the x. Now all of a sudden I can't put 1 in there, right? Because if I put in a 1, I'd have square root of negative 1, which turns out to be our imaginary number I. But what I can do is I can put a negative 1 in there, because then the negative of negative 1 would make it a positive 1. If I put negative 4, negative 4, it's 4. Square root of 4 is 2. So anytime we see that negative on the x, that's going to do what's called a reflection across the y-axis, and it's going to end up opening the other direction. As we go through our transformations, what we'll see is, so there's our parent function. If I throw a negative in front, I get a reflection about the x-axis, because now when I put in positives, there's a negative in front, and that reflects it down across the x-axis. But if I put a negative on the inside, that reflects it across the y-axis. So that's another way of looking at the same idea. Hopefully that covered it. Let me know if you still have questions.